So when I post it, it will be several small pieces. You don't have to go all the way. Okay, now this is treat this one as a new question. It has positive, negative, and lone pair. Based on our note 3, very bottom of that, where should I start with? Yeah, you always say.
You could move the lone pair as a double bond and then move the other double bond onto the oxygen.
Yeah, so that's very similar to our acetate, which is the example in our class. Or you can move it back. That would be just go back to the previous structure, right? So I guess are we all good with just keep moving to this side? Okay, so may I borrow another color from you?
Yeah.
Okay, so if we have this pair of lone pair, this blue, okay,
Yeah.
push it here, and then we have one blue bond, push it on oxygen. So this way, we will have, still going to draw the structure. If we haven't touched it, I'll use color black, okay? If it is parts that I haven't touched it, I will use color black. If it's the parts I just moved, I'll use color blue. So now, I guess that's kind of like what you were asking. Can you move it to single bond, double bond, whatever? This is another way of drawing the correct resonance structure, where some people can draw one step from the one that I erased, directly to this. You can push, it's kind of like previously the lone pair was here. You push it here, you push a double bond here, and you push it. Either works. Yeah, questions?
So would the top one or the bottom one be the major or the minor if you were just comparing these two?
None of this would be. But if you have to compare, I will take this one because oxygen is more electronegative than carbon, but none of this should be major because the previous one should be the major. Yeah. Okay, you are.
If you have like multiple structures, not resonance structures that you've drawn, say there's like 4 of them, would you only label it as major and minor, or would you have to write that like?
It will depend on the question you get. My TA make all those questions, and you can read the details. But it should be similar to a practice one. Okay.
If we're trying to draw all the resonance structures, is it more intuitive to start by moving lone pairs off of the nitrogen or moving them off of the oxygen?
You mean, should I start? Actually, can you rephrase the question? I did not quite get the question.
Like if we get like a original structure and we're trying to draw all the possible resonance structures, would it be easier to start with moving the lone pair off of the nitrogen to like kind of catalyze the rest of the structures, or to move the lone pair off of, or like onto the oxygen?
I guess so far we haven't really moved the lone pair on oxygen out. You see, this oxygen so far isn't being, so the simple way of answer yours is, it's not kind of like you always move. In resonance, we don't do that. It's kind of like, now, so far, this oxygen is only turned from 0 charge to -1. So far, in this example, it's only nitrogen is donating its pair of electron out. But can be a different case. It's kind of like case by case. Okay.
Because I was doing practice similar to this. I would always start by moving the double bond onto the oxygen. I'd end up missing structures like the one at the bottom where the carbon has the negative charge.
I would think this way. If you are viewing another structure like this, check, how do you know if you have kind of like a more structure? Confer with the charts. If it is possible to make the nitrogen or oxygen somehow, you can start with nitrogen or oxygen to see if that's all the happy formats already. Like when I view this one, the nitrogen was in one of the happy format, which you have more than one. So see if one of the other happy formats on my notes too can fit in this one. Would that clarify a little bit? People, yes?
How did you know to move the lone pair off of the nitrogen onto like this carbon, or into this double bond instead of that?
Okay, that's, if you remember on Monday morning, I showed a magnet. I said, okay, it's actually a good time to show the magnets here. When I have double bond like this, Okay, when I have double bond like this. So this is the double bond. Okay, this is the double bond here. This is the double bond here. The one that's below this was a sp3, which is the saturated one. Okay, so the one below this was a saturated one. It doesn't have this empty p orbital. So did you still remember I showed even today in the class there's an empty p orbital? The one below this carbon is saturated. It doesn't have that p orbital, so your electron cannot push into that one. Resonance, the fact of resonance is your electron moving in those orbitals. This one, sp3, is saturated, has already like no place for the electrons to keep jumping into. If that is clear in this way.
But like in the very beginning, when there wasn't a double bond there, like how did you know that this wasn't saturated? Like this was the very first. This is the original example. How did you know that this wasn't saturated? Like
because, okay.
Because there's a double bond here.
Yeah, the double bond was here, right? So so it's this way and this way.
Oh, okay.
Okay. Are we good with this?
When you say empty p orbital, are you talking about like if it's sp2, then there's one unhybridized p orbital, so that one's empty?
Yeah.
So,
So yeah.
the electrons can go into that area.
Yeah.
Okay.
Yeah, you will have more learning of the orbitals in discussion 2, which is kind of like you will see a lot of the small balls and the loop. You will see how they hybridize. Yeah. And the 2 of your TAs actually specially learn mechanism, which means all they're doing is those orbitals. So they are the expertise on explaining those. Okay? Are we all good with this rest? I hope you can see. I cannot see. Okay, maybe some people in the front can take a picture so you can see what the structure is. But anyway, I will post the videos, okay? Yeah, maybe post the video now, yeah.